In the last segment, you were to complete the rest of the exercises on the page, so check your work, okay? And remember that these are not the same. These have electrons like neon, an electron configuration like argon, electron configurations like krypton, and so forth, okay? Over here, we have our positives and negatives. Remember that there are 8 underneath. I'm just not drawing them. If you want to draw 8 underneath, you can, but it will be conflicting when we move forward. Okay, remember there's 8 underneath even if we don't draw it. Okay, and then the last is argon doesn't form an ion because it already has the octet. Okay, now you were asked to practice, so again, I'm presuming that you practiced either with your notes, more videos, with book homework, with anything that's on your Blackboard shell or provided for you. Homework, practice test. Don't move on until you understand this, okay? Because a key to moving on, so we're now in segment 3, is that you can make some general predictions from the periodic table simply by knowing the octet rule and the valence electrons. Okay, so alkaline metals are in group 1, so they tend to want to form a +1 ion in general. Alkaline earth metals, +2. We're skipping these. These don't have a name. So we're going to come all the way over here to group 7. 7 wants to be like 8. -1. Group 6. Gain 2. And so forth. Noble gases in general. No ions. Okay, so basically what you're doing is you're using your periodic table to count squares of how many squares do you have to go in order to be like these. Okay, so for example, strontium isn't going to be like xenon, it's too far. It's going to be like krypton, and we're going to lose 1, 2. Phosphorus isn't going to be like neon, it's easier to be like argon. In order for phosphorus to become like argon, it has to gain 1, 2, 3 electrons. Remember, each of these boxes is representing electrons. Okay? Iodine has 53. If it can gain 1 more, it becomes like xenon. So use your periodic table, okay? And understand that what's happening is that underneath, you're gaining or losing so that you get 8. Okay, remember there are some exceptions, hydrogen, lithium, beryllium, some of these right here because they don't even have 8 to start with. But what this is telling us is that 2 is like 8, and that's important to remember. All right, now the few exceptions, I talked about those, hydrogen, lithium, helium. 2 is like 8. And there are others that can have what we call an expanded octet. So depending on the class that you're in, if you're in a higher level class or a different type of class, you would be talking about expanded octets. So that's kind of like having a car with room for 8 passengers, but you're going to shove in a few extra. Legalities aside. All right, so now what about these right here and the heavy metals, tin and lead? Well, I'm just going to give you a list because the reality of it is the D block doesn't play by the same rules as the S and P block. Depending on the course that you're in, you will learn why, but usually that's left to a course for majors. So I'm going to give you a list, okay, and this you have to commit to memory, okay? All right, so they are what they are. They're just on a list. Iron can form a +2 or a +3. Copper can form a +1 or a +2. Lead +2 or +4. Tin +2, +4. Silver only forms a plus. Zinc plus is the same as +1, okay? Zinc will only form a +2. Aluminum is one of the few +3s, which is why I like to add it to the list. Gold, +1 or +3. And I think I'm going to put chromium on here. Chromium 2, chromium 3, chromium 6, even though I said there's not a whole lot of 3s. There are many, many more. Most of the larger metals and the D block will have more than one ion. Okay, so if you're in a different class, you would learn more from the list. Just depends on what your instructor is giving you. Okay, I'll add them to the list if we need to going on. Okay, please commit these to memory. Please make sure you can predict ions before moving forward. Because if you cannot predict ions, you cannot move forward in the course.